of the gates, this problem kind of puts us on our heels. The situation is this. Does too much sleep impair performance? And a study was done between of 12 subjects, and they wanted to find out if getting too much sleep slows your ability to react, impedes your vigilance. And what they did was they gave a test, and the faster you respond, the lower your number would be in this vigilance test. Now, folks with normal sleep, these are 10 subjects, 10 same people. So this is a paired test. Same 10 people. They took either a normal test and then an extended test. So normal test, subject 1 responded at a rate of 8. So maybe it took him 8 tenths of a second or 8 milliseconds to respond to something. Not sure what they're responding to. And then with lots of sleep, 2 hours extra sleep, also 8 milliseconds, okay? Or whatever their vigilance rating was. Subject number 2 we see had the same comparison. We see subject number 3 responded a little bit slower with extended sleep. Subject number 4 responded faster with extended sleep. Subject number 5 looks like responded much slower, as did number 6, as did number 7, as did number 8, all responding slower. Number 9 as well responds slower with having had too much sleep. And then subject number 10 looks like they have the same response rate. So right out of the gates, the practice problem asks us, if this experiment was properly designed, explain how the assignment of subjects to treatments could have been carried out. So would we want to test everybody with normal sleep and then test everybody with extended sleep, or would we want to mix it up? Now the correct answer to this one is that we would want to randomly assign treatment order, whether they get normal sleep intertested or extended sleep intertested, in a random fashion. So we would randomly assign treatments. That's the answer to number 1. Question 2 asks us to go on and carry out a t-test to determine whether extended sleep actually does impair performance. So it seems like for some people it does, for some people it doesn't, and for this individual, subject number 4, it actually went the other way. But are we seeing enough evidence to say that it actually helps? Now I feel like we have done step 1, our parameter population, null hypothesis, alternative, and significance level a lot. Step 2, our conditions a lot. So I'm just going to jot some notes real quick from that, and then we'll move on to step 3, our calculations. And this one, being a paired test, is a little bit different. So I'll say it out loud. The population we are talking about is all people who sleep, right? And we're looking at the true difference in response rate. Now, it's important when we're talking about the null hypothesis to show that the mean, we're talking about the difference. So I'm going to put a little notation. The mean difference is equal to 0. We could say this in another way as well. We could say mean of normal sleep, mu sub n, minus mean of extended sleep is equal to 0. It's a different way to think about it, but we're talking the same thing. We could say it in a third fashion too. We could say the mean of normal sleep is equal to the mean of extended sleep. All these options, A-okay. My alternative hypothesis is that the mean difference is, well, let's think about it. Greater than 0, less than 0. How they shape up in these other 2 ways of showing is really going to inform us of how it's going on right here. So let's look at it in terms of the bottom. We'll work our way up. So we have the mean of our normal sleep and the mean of our extended sleep, which one's gonna be bigger, right? We think the mean of the extended sleep is gonna be greater, right? We're saying their reaction time is slow. These numbers, on average, will be bigger than normal sleep. Let's look at it in terms of this. If I subtracted this right over here, so mean of normal sleep minus mean of extended sleep both sides, minus mean of extended, is going to be, our inequality stays the same, less than 0. When we subtract extended from normal, we're going to get a negative number. So less than 0. And so that parallels right there. The mean difference, less than 0. So you pick any one of these in order to show your null and alternative hypothesis. Just because you always want to go into it with a known alpha, we're saying 0.05. All right, I'll erase and we'll get to the calculations. Before we start with calculations, I'm going to look at the problem real quick and just speak to the conditions. Too much sleep. All right, so unfortunately, these are volunteers, so not a simple random sample. And it says nothing about reaction time being normally distributed. So we have to assume simple random sample, and we have to assume normality. So ultimately, we have a pretty weak study going on here. We're going to carry on just so we can get some experience with this, but the results of this study are going to be questionable. All right, our calculation, step 3. And this, if we're putting a title on it, is a paired t-test. Okay? T equal to sample mean minus my hypothesized mean divided by the standard deviation over the square root of n. Now, the way I did this was I completely used my TI-84 calculator, and I put the normal sleep in L1. I put the extended sleep in L2, and then in L3, my third list, I went L1 normal minus L2 extended. Okay? And then that self-populated, and that created me a list of differences in sleep times. Okay? And so what we're looking at then is we're going to conduct a t-test on L3. So when we go in and go over into our stats button, we click over to calc, and we go, or tests rather, and we go down to our t-test. We're going to use data from L3. So if you followed that, we're good to go. I've already done that on my calculator, so let's see what the results we get are. So stat, over to test, down to a t-test, and I'm going to use data. The mean we're expecting is 0. The list I'm using is L3, and again I want to pick the less than, so it matches my alternative hypothesis. I'm going to calculate, and this is what I get. I get a t-value of negative 2.577. Now, if you get a positive 2.577 here, one of two things has happened. You have either incorrectly entered your alternative hypothesis, so you said greater than instead of less than, or when you were doing your L3, perhaps you did L2 minus L1. If you did those backwards, then you're going to get positive numbers, which means it's, you're showing that it takes more time. And maybe that's just a different way to do it. Okay? With negative results here, we're saying you're a certain amount slower. With positive results here, a certain amount longer. So t of negative 2.577, that's way far away from the mean. Probability of that happening is going to be super low. It is super low. It is 0.015. So a result like this only happens randomly 1.5% of the time. Whew, not very frequent. Okay, so let's head over to step 4. Now we're probably masters of conclusions, so let's talk about our evidence, the choice we're going to make, and the context. So our evidence would be the p-value equals 0.015 is indeed less than alpha at 0.05. The choice, because p-value is lower, we are going to reject the null hypothesis. And what does that mean in the context of this problem? Well, rejecting the null hypothesis means that it seems reaction time is slower with more sleep. Asterisk on this because we didn't have a simple random sample and we didn't obtain normality. A larger sample randomized would produce more reliable results. Or something to that effect. You just want to say, hey, we didn't meet our conditions, so there's some things we could do to tweak this and get better results. All right, so there it is, a paired test. Pay attention to what data you put into L1 and L2 and which way we're subtracting and how that affects your alternative hypothesis. As an aside, however, I've seen this before in the past. The subjects, this stuff right here, subject 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, this does not go into your data set. This is just an organizational tool to help us keep our participants squared up. Okay, so don't enter 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 into your calculator. It's not data. Okay, it's just organization. All right, the numbers we're interested in, normal and extended sleep. All right, thank you so much, and hope this was helpful.